In this example, we're going to go ahead and solve this multi-step equation, and we're going to do so by solving for y, or isolating y. If you'd like to try this, go ahead and pause the video and do so, and then come on back and we'll work it together. Alright, so it looks like for this equation, the first thing I'd like to do is get rid of these parentheses, and I can do so by using the distributive property on both sides. So let's go ahead and do that. It looks like 2 times 3y will be 6y, and 2 times 4, of course, will be 8. This minus 2 comes along, equals, and then minus 3 comes along for the ride. So 3 times y is positive 3y, and 3 times 2 is positive 6. Okay, so that's what it looks like we have first of all. And now looking at these two sides of the equation, though, I have some like terms that I can combine. So let's go ahead and put the plus 8 and the minus 2 together over there first. And then on the right side, let's put this negative 3 and positive 6 together. So on the left, we'll have 6y, and then 8 minus 2 is a positive 6. And on the right side, we have this 3y, and then negative 3 plus 6 is positive 3. So this is what it looks like we'll have. Each side of my equation will have a variable and a number, or a constant. So to solve this, I'm trying to get the y's together on one side of the equation and the numbers, or the non-y terms, on the other side of the equation. So it looks like, let's go ahead and get the y's, or the variable terms, on the left side. And I can do that by, well, subtracting 3y from both sides. And I know that subtraction is going to be what I need to do, because this 3y here is positive, and really the positive means it's being added to this 3. So the inverse will be subtraction. And then, as well, this positive 6, I'd like to undo that addition. So I'm going to say minus 6 from both sides, and it's going to look just like that. So we did this in an effort to get the variables on one side, which they cancel from here, so we have the variables on the left, and the numbers on one side, which they cancel on the left, so they'll be here on the right. So 6y minus 3y is going to just be that 3y, and then we have 3 minus 6 will be negative 3. So we're almost there. We have 3 times y, and that equals negative 3. So the inverse operation of multiplying this by 3 would be dividing by 3. And again, because we're trying to isolate this y, get that all by itself. When we do so, we'll see that these 3's cancel, and y will equal, well, negative 3 divided by 3, which is going to be negative 1. Alrighty. So we're saying that the solution then for this equation is y equals negative 1. Let's go ahead and plug it back in and see what we get, see if it works. So we'll start out here on the left, so y is negative 1. So 3 times negative 1 is negative 3, plus 4 is 1. 2 times 1 is 2, and then 2 minus 2 is 0. So I actually get 0 over there on that left side. So hopefully we get 0 over here as well. So negative 1 plus 2 is 1. So 3 times 1 is 3. Negative 3 plus 3 is indeed 0. So we see that that works. The two sides of that equation are balanced whenever the value for y is negative 1.